All right, we're continuing to do more probability problems. So here's another example. 10,000 families in a certain town are categorized as follows. So if they didn't give me this 10,000, I would add up the total to get my total sample space of 10,000. So let's answer, what is the probability? As soon as I'm asked a probability, I know I need a fraction. That the sampled family owns a house. So owns a house is this over the total sample space. We're going to leave these fractions as fractions. If you were asked in decimal. This is 10,000, so you don't even need to really divide it out, but top divided by bottom. It's about 47.5%. What's the probability that the sampled family rents? Now it doesn't specify which rent, so I need to take both renter categories and include that. So that's 912 plus 2,857. About 37.7%. All right, we'll keep going. Next, it's asked, which of these numbers cannot be a probability? Okay, we cannot have a negative probability. That cannot be a probability. Half, 50%, that's fine. That can be a probability. You cannot have a probability greater than 1. Zero can be a probability, that's fine. 1. Whole is 100% of the time, sure. 20%, that can be a probability. Another example. If a card is drawn at random from a deck of cards, what's the probability of getting a queen? Well, there are 4 suits in a deck of cards. There's 52 cards total, and each suit has a queen, so there's 4 queens. So 4 out of the 52. I can reduce this to 1 out of 13. All right, another example. The blood groups of 200 people is distributed as follows. So 200 is my entire sample space. 50 have type A, 65 type B, 70 have type O, 15 have AB. If a person from this group is selected at random, what's the probability that the person has type O? Well, there were 70 type O's out of the 200. They're both, so 70 out of 200 is the probability. They're both divisible by 10, so 7/20. If I needed to do a decimal, top divided by bottom, which is 35%, 2 times. So 35% of that group is type O. Keep going. So the following table represents the number of cars owned by households surveyed. So first I need how many total households were surveyed. So I'm going to add this up. That's my sample space. So let's answer some probability questions. What's the probability of a household owning 1 car? That's specifically 679 out of the total. I'm going to write these as a decimal and 0.3081. I rounded to 4 decimal places. Next, what's the probability of a household or owning more than one car? Okay, you have to understand what are the outcomes? More than one car. So that does not include no cars, and it does not include one car. It has to be more than one car. So it'll be these three numbers added up. So 841 plus 208 plus 98 out of the total sample space. So 841 plus 208 plus 98. 1147 divided by the sample space. If I round to 4 decimal places, it's going to stay at 4, so 0.5204. Sorry. Alright, and lastly, what's the probability of a household owning less than 3 cars? So, what numbers are less than 3? That does not include 3 or 4 or more. So the numbers that are less than 3 are these ones. So these are the ones I'm adding up. So 0, 1, and 2. So if I round to 4, I got 8, 6, 1. That's in my fourth, but that's a 6, so I gotta go up to 2.